Yeah, hopefully it'll work. I mean, the one yesterday didn't really. So, okay. So for this first part, I just kind of want to tell you what homework 2 is about, and then we'll jump into it. So, yeah, so we're going to start talking about trig functions. For all real numbers, which we kind of already did this a little bit in the first one. And we started out with acute angles like being in right triangles and whatnot, but then we did talk a little bit about the unit circle. So that's the general definition. So you got, here's the unit circle. I didn't draw my axes very big. All right, so sine of theta, by definition, is you go theta, however many times it is, wherever you're going. So there's a big value of theta. I went around the center a lot of times. But wherever you wind up, you draw a line from the origin out to the edge of the unit circle. Sine theta is the y-coordinate on the unit circle. All right, and then same thing, cosine theta is the x-coordinate. Coordinate has 2 O's in it, doesn't it? Yes. And then tangent theta is y over x, which if you remember back from your algebra class, since we're starting at 0, 0, change in y over change in x back in algebra, what do we call that? Slope. So tangent theta is the slope of that radius. All right. And then again, secant is 1 over cosine, cosecant's 1 over sine, cotangent's 1 over tangent. Okay. So going along with that, there's a few little tricks that people use to kind of help. The first one is reference angles. So what a reference angle is, it's the smallest angle between wherever the radius you draw. It's the angle between that radius and the x-axis. So angle between your radius and the x-axis. So let's just do a simple one. Let's say our angle is 240 degrees. Right? So 240, well, from here to here is 180. So we're somewhere around there. So that's 240. So my reference angle would be, so I look at my radius. Where's the smallest angle between that radius and the x-axis going to be? Is it going to be going forward or going backwards? Going forward versus going backward.
So the x-axis is backwards.
Yes, yeah, it's this one right here. All right, that's shorter than going the other way. It's always going to be an acute angle, so that might help you out. So, all right, so if that's 240, I know how far is it from the beginning to there? 180. So what does that make this reference angle here? 60. And the thing about yes. And then okay, so if it was like here, then the reference angle would be 9. So it's same both directions. It's just, yeah. Okay. So my reference angle is 60. And the good thing about reference angles, if I do any trig function, so sine, cosine, tangent, any of them, the trig function of the reference angle is the same as the trig function of the angle you start with, except the signs might be wrong. So like if I wanted to know cosine of 240, well, if some evil mathematician or math teacher sometime made me memorize cosine 60, did some evil mathematician make you memorize cosine 60? No? Okay. So cosine 60 is a half. We'll do that here in a minute. We haven't done it. We talked about it a little bit before. So cosine 60 is a half. So that means cosine 240 is, well, it's either a half or it's negative a half. Is it a half or negative a half? Yeah, it's negative because cosine is the x coordinate. If I look over here, yeah, the x coordinate, whatever it is definitely negative. So apparently cosine 240 is negative a half. And let's go ahead and just do one more. Let's say we do, what about cosecant of 240? So that should be the same as cosecant of 60, plus or minus. Right? Cosecant is 1 over sine or cosine? Sine. Yeah. It kind of feels backwards that cosecant goes with sine and secant goes with cosine, but you get used to it. So what's sine of 60? What was that?
Is it still half? Is it still half?
It's not half. That's actually really close, but no. It's the square root of 3/4, which is root 3 over 2. So this is 1 over root 3 over 2. So it would be plus or minus 2 over square root of 3. Or if you wanted to get rid of this, the denominator, you could go 2 square root of 3 over 3 if you like that better. Yeah, it just depends on whether they ask you to rationalize the denominator or not. And is it going to be plus or minus? Yeah, again, it's minus because sine is the y. If I look at my picture, the y coordinate down here is definitely negative, so it is minus. So minus 2 over root 3. All right. Cool. So that's reference angles, which is a good thing. Makes you kind of only have to remember that first quadrant, which actually, let's go ahead and write that down. We'll use Angel's trick. You like your trick, Angel? Yeah, 1, 2, 3, 4. So 0, 30, 45, 60, 90. So these guys you just need to learn. So sine, oops, cosine. You don't actually have to learn tangent because you can divide sine by cosine to get tangent. But wow, somebody is listening to Canon. Okay, so 0, 1 over 2. This is root 2 over 2. This is root 3 over 2. And if you want to keep the pattern going, well, 90 is 1, but you could think, hey, that's root 4 over 2. So it's like root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. No. Okay. And then if you remember the sine, you can remember the cosine because it's just backwards. So it's 1, and then root 3 over 2, root 2 over 2, 1 over 2, and 1. Not 1, crap, 0. And then tangent. Well, tangent is sine over cosine. 0 divided by 1 is 0. 1/2 divided by that is 1 over root 3, or root 3 over 3 if you like that better. Root 2 over 2 divided by root 2 over 2 is 1. Root 3 over 2 divided by 1/2 is root 3. And 1 divided by 0 is undefined. All right, cool. So these you really need to learn. The rest of them, I mean, again, if you can just do the reference angle thing, you say, okay, well, I ask you, what is cosine of 315? Well, okay, let's do that real quick. So cosine of 315, first thing is draw 315. Yeah, it goes all the way around to quadrant 4, and then there's a 45-degree angle left. Right. which means that cosine 315 is going to be the same thing as cosine 45, except the sign might be wrong. So what's cosine 45? Oh, you can't quite see. Cosine 45. Root 2 over 2. And now the only thing is this one going to be positive or negative? Yeah, if I look at my x-coordinate here, it is positive. I mean, x is that way, so sure enough. Boom. Cool. Okay. I think really the only other thing in here, besides what we've already talked about, is that these are all periodic. So if you go 360 degrees, you're back where you started. So, so in degrees, you have sine of theta plus 360 is sine of theta. So this is called a periodic function. When, if you add a number in, you still get the same function again. So if you add 360, it's the same. Naturally, if you add 360 twice, so if you add 720, it'd be the same. If you add 1080, it'd be the same. Same thing with cosine. So cosine theta plus 360 is cosine theta. What about for tangent? What do y'all think? Let's go back to our picture of the unit circle. In the picture, tangent was the slope. So if I start with a line, how far do I need to go to find a line with that same slope? If I go 90, I'll wind up there. Is that the same slope? Yeah. If I go 360, yeah, definitely I'm at a line with the same slope. But do I get one earlier than that? I don't know why that. Yeah, you can go 180. I was about to say, I don't know why one node is restarting. So tangent is actually kind of the weird stepchild. Okay. That has stopped working. But the only thing I was going to do was write down tangent of theta plus 180 is tangent of theta. So then I'll try to start one node back up. Okay. Okay, there we go. Cool. Yeah, so tangent of theta plus 180 is tangent of theta. All right. And then, of course, this is all in degrees and radians. It'd be 2 pi or pi. But yeah, okay, cool. So that's kind of what